Now sometimes, rather than expanding and breaking apart a logarithm into multiple parts, we want to condense them down into one thing. And so it kind of works in both directions then at that point. So let's kind of work backwards from where we were in the last few examples by condensing a logarithm down into a single logarithm. The first one is going to be log of 7x plus 6 subtracted by log x. Now keep in mind when we look at these and we see the subtraction between the two, that goes back to the quotient rule. And the quotient rule had to take the division and change it into subtraction. So if we have subtraction, we can combine these back together again into a single logarithm where we'll have division of something on top and something underneath. What would go on top would be the 7x plus 6, and what would be underneath is the x. So that's what the quotient rule tells us we can do to condense this back down into a single logarithm. Here's another situation where we're going to condense the logarithms back together again. 1/2 log x plus 4 log x minus 1. So notice how we have these numbers in the front of the logarithms. The power rule is what allowed us to put numbers in front from the inside of the logarithm. So in reverse, we can take these numbers and move them back to the inside as a power on the inside of the logarithm. So what that would change this to is log x raised to the 1/2 power, and then another log x minus 1 raised to the 4th power. So now we've moved those numbers back above inside the logarithm. Now the next thing to notice is these two are being added together. When two logs are added together, that had to deal with the product rule. So to join these logarithms back, we can actually change it into log and bring together the two things, the x to the 1/2 and this x minus 1 to the 4th, bring those back together again, and they'll go side by side, multiplied together inside of one logarithm. So the addition converts back into multiplication with the two things from each of the logarithms by the product rule. And more or less, this is about all we're going to do just to join things back together again. But oftentimes, when we're done, we'll take those fraction powers and change them back into roots. So for the 1/2 power, I'm going to go ahead and change it back into a square root since I'm done combining everything back together again. Now let's look at 3 ln x plus 7 minus ln x. The first thing I'm going to do here is notice that there's that 3 out in front. The power rule again tells me I can move it back to the inside of the logarithm, turn it into the exponent. So this would change it into ln x plus 7 raised to the 3rd minus ln x. Now if you think you know what would happen next here, you may want to pause the video and write out what you think the last thing would look like as a result of condensing these two back together again. Indeed, we have subtraction here, so that would go back to the quotient rule for logarithms. And so we take the subtraction, combine these together into one logarithm with division. So ln x plus 7 raised to the 3rd divided by x would be how this would combine together again. Now here's one with several logarithms to combine back together again. 3 ln x plus 5 ln y minus 6 ln z. So we're going to take it step by step to combine each individual logarithm back together again. The first thing we can do though is take these powers, or I should say take these numbers from the front and put them back as powers on the inside by the power rule for logarithms. So that would change it into ln x to the fifth, ln x to the third plus ln y to the fifth minus ln z to the sixth. Okay, and now we've got both subtraction and addition going on here. I'm going to take care of the addition part first, and that would involve the product rule. So what that tells me to do is to combine these logs into a single logarithm, so just one ln. I take the x cubed and the y to the fifth and put them side by side so that they're now multiplying each other inside of one logarithm. So that's the product rule. And then we still have minus ln z to the sixth. And now we have just the subtraction left. And that's going to go back to the quotient rule. And so to do the quotient rule again, we have to take the subtraction, combine it into one logarithm, and we have division. What will go on top is x cubed y to the fifth divided by z to the sixth. Here's another situation we sometimes encounter. Here we have a 1/3, and then in parentheses we have two logarithms which are subtracted. My suggestion when you have parentheses is to go ahead and distribute that number into the parentheses. So let's change this into 1/3 log base 4 of x minus 1/3 log base 4 of y. Now the 1/3 sits in front of each of the logarithms. And what our log rules tell us to do are to take that and move them inside the logarithms to make them back into the exponents above each of the variables. So that would change it into log base 4 x to the 1/3 minus log base 4 y to the 1/3. Now since these are subtracted, we can combine them back together again using the quotient rule. Log base 4, and then on the inside we have x to the 1/3 on top and y to the 1/3 underneath. And now for my last step, since these are fraction powers, usually we'll change them back at the very end to the cube root. So cube root x divided by cube root y. Now let's take a look at this one here. 4 log base b of x minus 2 log base b of 6 minus 1/2 log base b of y. My suggestion to start on questions like these are take the numbers that you have in the front and move them back on the inside. Since the goal of these questions are to condense the logarithms down, it's usually best to go ahead and take care of those first. So I'm going to change this into log base b of x to the 4th minus log base b of 6 squared minus log base b of y to the 1/2. And so now we've taken care of those things, the exponents by the power rule. But the curious thing is we have a minus and then another minus. To help make this a little bit easier to deal with, I'm going to factor out a negative. From the two negatives, I'm going to take away a negative. Now that's kind of weird sounding, but the way that it would look was what I'd have here is log base b of x to the 4th minus log base b of 6 squared. Now I'm going to put this in parentheses here, and since I'm taking a negative from a negative, it's going to change it into a positive. Log base b of y to the 1/2. That helps us out here because now the negative can be changed to a positive. So really all I did was I threw parentheses around these two and put the negative in the front, and that takes care of the negative for us to change it into a positive. And that's great because addition between two logarithms can certainly be joined together by the product rule for logarithms. So we'll have your minus log base b, and when I combine these together, it's going to change into 36 y to the 1/2 power. I'm taking the 6 squared and making it into a 36 and joining it together with the y to the 1/2 power. That's what it tells us to do since these two are added together. Now we're left with just two logarithms and they're subtracted. So that goes back to the quotient rule for logarithms. This would be log base b, and on the inside we'll put x to the 4th divided by 36y to the 1/2 power. And the only thing I would do from here is, since we're at the very last step, I'll go ahead and change that fraction power of 1/2 and make it into square root y. So here's a practice example to try on your own. Pause the video here and see if you can condense these together into a single logarithm. And when you start the video back up, I will go ahead and show how it's worked out. So the first thing to do is to move these numbers back to the inside of the logarithm. So that would be ln x to the 1/2 plus ln y minus ln z to the 7th. Okay, and now notice these two are added. So what I'll do is I'll combine them back together again. We'll have x to the 1/2 y minus ln z to the 7. Now since these are subtracted, we'll combine them back together with division. ln x to the 1/2 y divided by z to the 7th. And now the only other thing to do is go ahead and change the 1/2 power back to a square root. So we would make that square root x times y divided by z to the 7 power.